So first I'm going to be solving using the quadratic formula. We know that the 5 is a, the b is 7, and c is the -3 as of right now. We know that it is c because it's the only number without a variable. Now we are going to be finding the discriminant, which tells us how many solutions will be provided when we use the quadratic formula. So I'm plugging in all of my numbers and then doing the calculations on my calculator. The number itself from the discriminant is not important in this case. What is important that we know is that d is greater than 0, which means there's going to be 2 solutions. So now that we know that, going back to the original equation, we want to be able to isolate the x. By doing this, we are subtracting 2 from the right side of the equal sign and adding it to the other side. Now that we found the discriminant, we know that there are 2 solutions when we plug it into the quadratic formula. First, I am multiplying 7 squared and then -4 inside the brackets. Although I solve from here in my calculator, I am bringing it down one more step. First, I'm typing it in with the positive sign, and then I'm typing it in with the negative sign to find x1 and x2. These are the x-intercepts in this quadratic equation. When we type in the equation with the minus, we get -1.9, which I round to -2. And when we are adding, we get 0.5, and that cannot be rounded to any number. So now we're solving a quadratic equation by factoring. So looking at this equation, we know that the first step we can do is take out a 4 from each variable. Now, just like what I do in regular factoring, I'm going to be drawing this x, and looking at my equation, I'm going to be asking what multiplies to 3 but adds to -4. And the numbers that I got is -3 and -1, and I will be adding that in my equation, which will be replacing the -4x, which is also our b value. And now that I've done that, I like to pretend that there are little brackets there separating off the 2 sets, and the goal is to get them to be the same on both sides. So now I ask myself, how do I get them the same on both sides? And for the first one, I take out an x, and the second one, I can take out a -1, which makes both sides equal x minus 3. So because we took out an x and a -1, we can actually make that our second bracket. So now that both sides are x minus 3, we can combine those and make it x minus 3 and then x minus 1, which is what we took out. So now that we have these values, which is r and s, we flip the sign and we have 2 x points. And of course, y will equal 0 because this is a quadratic equation. So because we are graphing this equation, we need to find the maximum or the minimum, and that also works as the vertex. So this will give us either our highest or our lowest point in the parabola. As this was in factored form, we use the equation h equals r plus s over 2. So when we finished writing it in factored form, we did not have to change the sign just yet, but we will be doing that in this step either way, so I just did it ahead. So now that we know that h equals 2, we want to know what k equals, so we are going to be plugging 2 back into the original equation, and h acts as the replacement for x. So I am just solving it as I would solve any other equation. I am just replacing all of the x values as 2, which is our h value. And with doing that, we find out that k is equal to -4, and we know that hk is 2, -4. Which is also our vertex, and I'm going to plug it into a graph to see if it's a maximum or minimum. So now going back to when we found x1 and x2, we are going to be plotting that, and those are our 2 x-intercepts. And of course, we have our h and k value, which is the vertex. When we draw our parabola connecting all of the plots, we see that it opens upwards, meaning that it is a minimum because it is at its lowest point right now. So now we are going to be solving quadratic equations from vertex form, and looking right off the bat, we can see that it is going to be positive 4 and 2. The reason it turns positive 4 is because we're multiplying a negative in, and two negatives equal a positive. So what I am doing now is I am expanding it because I want to find the minimum and maximum. So this part is super fun because I am doing the FOIL method. And finally, I am collecting like terms. And now it's in standard form and we are ready to put it into the quadratic formula. I just skipped the part of me writing it all out and then plugging the numbers in, and now I'm just solving how I normally would using BEDMAS. So now we have x1 and x2, which is 3.8 and 4.9. Now I can find whether it is a maximum or a minimum. Here I was just drawing my little graph and plotting out the points. I already knew my vertex from the original equation. So now I'm going to be using standard form to find whether this equation is a maximum or a minimum, and the formula for this is h equals negative b over 2a. You can see in my original equation, 7x is the b. So we could have kept it as a fraction. It may have been a bit easier and gotten us a more solid answer, but my calculator does not do fractions. I'm not sure what's wrong with it, so I was just showing you here. That's why I put it into a decimal, which is usually not what you're supposed to do. Anyway, so now I am plugging in that h value back into my original equation, which was in standard form. So now that we have our k value, which we could also write as our y value, we have our vertex point in this parabola. So now we are simplifying radicals, and I am asking myself what the square root of 32 is, So from there, we can't square root the 2 to make it any smaller, but we can still see about the 16, and the square root of 16 is 4. So then we take the outside 13, multiply it by 4, which gives us 52 to the square root of 2. So there are different ways I could have solved this entire radical question, but first I decided to multiply the 16 under the square root. So by doing that, it's almost like working backwards. I would do 16 times 16, which is 256, and the square root of 256 would end up being 16 again. And the 25 is already under a square root sign, so we already know that that's taken care of, and we just multiply those together. Now for adding and subtracting radicals, first we look to see if there are any common numbers under the square root, and the numbers outside of the square root next to them, we just multiply them together and keep the number under the square root the same. And I do that process with as many pairs or numbers I can. So after multiplying the numbers together, this is what I got. Now I'm doing inverses, and the very first step you should always do is switch the x and the y and rewrite it. So I want to isolate the y, and to do this, first I am bringing over the negative 2, and On the right side, we are multiplying it in, which means to bring it over, we need to divide it. Next, to get the exponent taken care of, I am just showing that both sides are square rooted, which gets rid of the exponent. And finally, to get the -3 to the other side, I am just adding 3 to both sides. And I'm putting that 3 in front, saying it's to the plus or minus of the square root of the number we got.